Hello friends. So today we are going to discuss some topics of Boolean algebra. So first of all, we will explain that how we simplify the Boolean function, or we can say simplification of Boolean function. Okay. So any logic expression can be expressed in the following two standard form. So there are two standard form in which we can simplify the Boolean function. One is SOP and another one is POS form. This SOP stands for sum of product and POS stand for product of sum. Product of sum. So these are two forms in which we can express any logical expression. Okay, so these two forms are suitable for reducing the given logic expression into simplest form. Okay, so this is the use of these two forms. So we will explain one by one how we express this SOP and how we express POS. So first of all, we will explain what is SOP. As we know that the SOP stands for sum of product. In this form, we will write the function as y is equals to AB plus AC plus BC. Okay, so this is our Boolean expression. What is y here? It is how we can show the output, or we can write this y as f function of A, B, C. Why A, B, C here? Because in the expression we are using three literals. What are literals here? This A, B and C. A, B and C, they are literals, or we can say input of the combinational circuit. Okay. So how this is in this expression is in SOP form. See, AB, this AC and this BC, they are called as product terms. And now we take the sum. This and this sum. So we are taking the sum of the product terms. So this is how we will express the SOP form in the following manner. Okay. Now this sum and the product term in the SOP form, they are not the actual addition or multiplication. Okay. So this is this product and this addition. They are not the actual addition or multiplication. In fact, they are or and A and D and functions. Okay, so this sum and product, they are actually or and function. Okay, now we take some more example of SOP. Suppose if we have y equals to ABC plus BCD plus AB D bar. Again, these are ABC, BCD, AB, D bar, they are the product terms, and we take the sum of these product sums. So therefore, this is a SOP form. Okay. One more important point is that thus in each product term, whether it is ABC, BCD and ABD bar, it contain one or more than one literals, and which are and together. Okay, and the literals ABCD, there are four literals here, and the literals can be in their complemented or in uncomplemented form. Okay, so this is SOP, sum of product. Now we will explain what is POS form. So POS is product of sum. So first we will take some example. Suppose if we have an expression like y equal to A plus B dot B plus C dot A plus C. Okay, so how many literals are there? There are three literals, so we can write this y as f function of A, B and C. Okay, or we can write it as directly y here. So A plus B, B plus C and A plus C, they are, all these three are sum terms, and we are taking product, this dot, and we are taking product of this sum terms. So this is how we will express the product of sum form in the following manner. In the same way, the literals are here odd together, okay, to form the sum term. Okay, and the sum terms are n together, and the sum terms are n together to get the expression in the POS form. Okay, so this is how we will express SOP and POS form to simplify the Boolean function. Okay, now we will take one more topic related to this, and that is canonical form. Canonical form, or you can say standard form. Okay, so what is canonical form here is, so what is canonical form? Canonical form, or we can say standard form. Standard form. Okay. So the word canonical is used in order to describe, a condition of switching equation or switching operation. Okay, so this standard form is used. The meaning of canonical is conforming to a general rule. And the rule, what is the rule here? The rule states that each term in a switching operation must contain all the available input variables. Okay, input variable, or we can say the literals. Okay, so as we know that there are two forms, SOP and POS form. So in the similar manner, we have two standard form or two canonical form, that is standard SOP form and standard POS form, in which we have to keep in mind that all the literals will be contained in that expression. Okay, so how we can explain is, suppose if we take the same example of SOP. In SOP form, if y equals to AB plus AC plus BC. So how many literals are there in this expression? There are three literals, that is ABC. So in whole expression, in this what is missing? In this C is missing, in this B is missing, and in this A is missing. So therefore, this is not the standard SOP form or standard canonical form. But if the expression is just like ABC plus A B bar C plus A bar B C, then this form is a canonical or standard form, because all the three literals are present in the each product term. Okay, whether they are in complemented form or in uncomplemented form. Okay, so this is how we can show that whether the following expression is a standard form or in canonical form. Similarly, for the POS form, okay, if we take example y equals to A plus B, B plus C, and dot of A plus C. Again, there are three literals we are using ABC, but in this sum term C is missing, in this A is missing, in this B is missing. Again, this is not the standard POS form. Okay, so we have a procedure to convert a normal POS or SOP form into a canonical or standard form. So how we convert it, we will explain in the next lecture. Okay, so if you have any query regarding this topic, then you can ask in our comment section, and keep watching our video. Thank you so much.